Welcome everyone. Today we're looking at smart meter reads and 21 surprising ways you can use them in your utility operations. Now, over the past couple months here, we've been through a couple of webinars on the evolution of the smart meter, right back from the 1800s all the way through to today's fully connected real-time systems. And we touched on a lot of the motivations behind those evolutions. If you did miss them, you're welcome to visit cleargrid.io, and all the recordings are up there for your viewing. And now we're going to take a look at and think through some of what we do with this data. You know, we need to create some value adds with this for the utilities, the consumers, and the regulators. So how do we do that? And on today's webinar, we're going to discuss 21 of those use cases for the data. And some of these uses weren't even dreamed of when the smart meters were first created. So there's some really new ones with some of the ways the industry is evolving today. As always, happy to answer any questions as time permits. Please enter them in the chat box and we will either address them at the end of the webinar or we'll do a follow-up with you on them. And I'll start with some quick introductions here. I'm Ellen Christopherson, CEO of clearGRID, and clearGRID specializes in the collection of AMR and AMI smart meter readings, and we do this from the air. I also have Ross and Dave joining me today. Ross Malme is the inventor of the world's first and most successful radio frequency utility meter. And Dave Hyland specializes in smart grid strategies, demand response, and supply management. Thank you both for joining.
Thank you for having us.
We have gathered 21 value-added use cases for meter readings. And this is a really unique aggregation, and it spans many aspects of the utility business. What we've done is sort them into 5 categories. The first category we've got is IT/OT, so our information and operations technology. And this is a lot of the traditional uses for the information. Next, we've got operations. This involves a lot of the day-to-day side of the utility. And we've got a category fully around rates and customer apps, so the way the consumer interacts with the data. And there's a surprising number of these. Finally, we've got the more recent applications involving retail. All of these applications are already possible. They're already in use today. It's somewhere. And some of them are more specific to a specific utility, maybe electric, others might be more for water and gas, and others span for all 3 commodities there. And we'll jump right into the first category here, IT/OT, with our first use case on billing. And this is really the core of, this is the reason that the meter exists. It's what produces the necessary data to actually bill the customer, which is the cash register of the utility. So without this, nothing else is important, really. Nothing else happens. And historically, this was actually the only way that utilities communicated with the customer. So the utility sends the consumer the commodity, the consumer uses it, the utility bills the consumer pays, and that's the end of the transaction. So very, very simple. And really, as we go through these use cases, we'll see that there's a lot of other ways for the utility to now interact and add value for the customer. So we'll continue on with those, starting with forecasting. Ross, I'll pass it to you.
Thank you, Ellen. Yeah, forecasting is a critical application for almost all utilities. And basically, what you're doing is taking historical meter data and being able to take a look at what that actual was, and that, along with weather data, you're able to forecast what the load should be on a given day. And that's used not only to determine what we would call resource adequacy, making sure that the utility has got, if in the case of an electric utility, adequate generation reserves to be able to meet the peak demand of that forecast. And also it's as you get closer to real time, this forecasting data is started to be used to determine unit commitment. So utilities, when they do their unit generation commitment, generally they're going to take their least cost assets, usually assets like coal plants, gas generators, and so forth, and commit them to the stack, and then use more expensive resources to actually hit the peak demand as you get closer and closer to real time. And also this forecasting data is used for the next application, which is trading. I think Dave's going to talk to us about that.
Yeah, thanks, Ross. Yeah, a lot of times when utilities decide what asset to use, that's called a picking order. Well, there comes a time whether with the utility when the pecking order they're short. So at some point in time, whether the utility generates their own power or if they actually actively trade the power, buy and sell over the internet or whatever system that they have, they've got to invoke their trading options. So every utility uses that. Price becomes a major factor, but then again, the forecast is a major factor in trading, whether or not the utility is going to be short of supply for the forecasted demand, or they're going to be long, and then they can trade that out on the internet. But trading is a very big user of pricing because that really is what drives the transaction along with the forecasted need for the utility.
So the next app that we've got is usually determined by water and gas utilities. And I think, Ellen, you're going to take that one.
Yeah, on the operations side for leak detection. Yeah, this is a particular use for both water and gas, as Ross said. And really on the water side of things, the magnitude of the losses here can be quite significant. Some water systems can be up to 50%. So being able to really understand what's going on in the system, where the water or the gas is actually being consumed, and then use basically the negative space of that to determine the magnitude and the location of possible leaks. That this is becoming more and more of a use case for a lot of utilities to help with manage their system. On a similar vein to leak detection is theft detection. This is also known as non-technical losses. And for some utilities, just like leaks, this can be a huge revenue loss. For some countries, I know this can be actually up to about 50% of the consumption. And for consumers, this is actually a big deal too, because everyone has to contribute to the total cost of supplying the commodity. So making sure that there's a handle on where all of that commodity is going, and when there's any kind of theft involved, being able to actually do something about that. So the algorithms basically use algorithms to develop predictive customer usage, compare that against the meter reads, and determine if there's an instance of theft. Ross, over to you again.
Yeah, okay. So the next application is more applicable to electric utilities, and it's really what we call VAR detection. And if you think about most or all electrical systems, as power leaves the substation at a certain voltage, it as it moves down closer to the load or towards the end of the line on that feeder, the voltage will start to drop. And the utilities have to maintain that voltage within a certain fairly tight band, or that could really cause problems with certain types of equipment like motors and so forth. And the notion of volt VAR, there's really two things that are being measured here. One is what's called real power, which is voltage, and the other one is called reactive power, which is VARs. And think about this: it's what happens when you have certain kinds of loads on the system. For example, an electric motor is an inductive load, and it will move the phase angle a certain direction, and then you've had capacitors which will move it in the other direction. And increasingly, as we now have more distributed energy resources on the system, it is really important that the utility be able to measure real and reactive power on the low voltage side of the transformer in close to real time. And so in one application, when you've got solar PV on a feeder, being able to control the voltage on there, you can maybe increase the hosting capacity for solar on that feeder by maybe 50% more, or maybe 100% more, or even more. So that's becoming a very, very critical measurement applications in smart metering. Another one is that I'll talk about. This one is applicable to gas and water meters. These devices historically have been positive displacement devices, and effectively they wear out. So over time, these water and gas meters will begin to wear, and which they will begin to slow down. and that means the utility is losing revenue, yeah, revenue for those meters. And typically the utilities will either have a scheduled meter change out program to refurbish those meters or replace them with new ones, or they'll have some kind of sampling system that they'll go through to determine which of these meters or which groups of meters are getting slow and need to have that change out. Which brings us, I think, to our bonus question.
Our
Ellen,
bonus
you're
here,
muted.
Dave will,
Yeah, the
Dave will
bonus.
talk about, but it's just as a note here, it's not actually using the smart meter readings itself, it's more using the platform of the smart meter.
Yeah, so the interesting thing is a lot of times utilities are looking for the opportunity to reduce their costs, whether it's rolling a truck, rolling people. So a lot of the newer smart meters have remote connect, disconnect capabilities. What this means is a utility can, if they've got frequent move in, move out, like a college, university, or someplace like that, or a no pay situation, they can actually turn the power off or turn the power back on without rolling a truck and scheduling people from doing other necessity things to keep the grid up and running. So it's a nice bonus for a utility. They actually use the utility communication network. So you'll see that more and more as time goes on. The next topic that we've got are rates. And a lot of times talk about load research. Load research is developed or has been developed to group customers, like customers together, so utilities can understand exactly how and when they use power. This is done so they can develop special rates, more accurate rates for those customers. And once they develop those rates, they can actually keep customers to get customers to use power at a better or a more appropriate time. So when they're looking to pay a bill or they're looking to switch, the load research people really understand the customers probably better than the customers understand themselves. They actually aggregate customer load profiles, which is what Ellen's going to speak to here.
Yeah, so once you've got the research done on the individual and the individual consumers and understanding their profile, what really happens for the utility is being able to aggregate that together and group them into similar classes. So, you know, maybe for residentials, you're going to base that based on what kind of not only what kind of house they live in, but also what kind of patterns they have for consumption. You know, maybe retail store is going to be different than a gas station. Being able to actually group all those together, that feeds in then into their rate structure, into the forecasting, being able to really pull that through a whole bunch of other stuff in the utility to serve the customer better, and of course be able to be more profitable while doing that. That's really what it comes down to there, and that feeds back into our next use case with the dynamic rates.
Yeah, so with dynamic rates, the idea here, you know, with smart meters, it really enabled this. And we have, you know, interval data where we can have different pricing structures based upon the time of day. And effectively, you know, what's going on here is the electricity in particular is one of the most, if not the most price volatile commodities on the planet. And with traditional metering, all of that price variability is basically on the responsibility of the utility. With dynamic rates, what the utility can do from a risk management standpoint effectively is transfer some of that price risk to the retail customers. And it's not advertised a lot when utilities go in for smart metering programs, but effectively this is what's going on is it's a risk management tool to be able to transfer some of that risk to the retail customer. And why that's important today is as we continue to take more and more fossil-based generation off the grid, and we put more and more renewables on the grid, we lose something called inertia. I mean, basically, when you got a combustion turbine turning, you know, it tends to want to keep turning. Well, when you've got that replaced with a solar panel or a wind farm, sometimes the wind doesn't blow. Sometimes a cloud comes over the solar farm, and you can drop the output of that very, very quickly. And that affects prices a tremendous amount. So being able to have some type of dynamic pricing tool in the utilities toolkit is really, really important.
Yeah. So the dynamic rates actually put the use of power into the customer's hands and let them make a decision. In the past, what we've had is something called demand response. And when there's a price or supply volatility in the marketplace or in the grid for the customer, because electric is the most volatile commodity out there, what utilities have done in the past is they've managed that supply and demand by actually curtailing the use of power at a customer location. So for example, let's say they're running some type of process and there's a short supply of power in the marketplace and the price goes up. Well, rather than the utility saying, okay, I'm going to buy extra power at this amount, what they'll do is they'll have an agreement with the end customer, and the customer will say, okay, because they get a special price. But at the end of the day, what happens is the utility can control one of the processes at the factory, or even at somebody's home, where they'll curtail thermostats or curtail air conditioning, or even curtail electric water heaters. So this is what's known as demand response. On the other side of that is there's also companies out there other than the utility that will go out and contract with either commercial, industrial, or even residential customers, aggregate those together. And when the utility finds a need to invoke demand response, the third party will actually act as a virtual peaking plant or a VPP. And actually, instead of increasing the power into the grid, they'll decrease the power in the grid. There's a relationship between the consumer and the VPP provider, and the VPP provider will pay the consumer, where the utility will pay the VPP. So it's another transaction with a middleman involved in the middle of the responsibility between the utility and the end consumer, which leads us to customer apps. And it's interesting because customer apps, since the spread of meter data, you see customer apps move from very, very simple applications to very complex apps. And the first one is customer use feedback. And basically in the past, the only time a customer ever knew how much power they used or they had used was at the end of the month when they got their bill and there was a number because the guy read the meter. Today, there are many applications where customers can see their energy usage in 15-minute increments. This is really a great thing for customers to be able to control their electric use because they have more information on what they're using. And that will feed into appliance signatures, which Ellen will talk about.
Yeah, one of the pieces of information that can be gained out of this is the appliance signature monitoring. This using technology to analyze the customer load data and actually tell which specific appliances are turned on and off. And this is done by a load signature, and refrigerator has a different one than dryer or a dishwasher. This information is valuable for the utility and for the retailers, and it feeds back into load research a lot. And a unique application actually of this could be that you have an ad pop up for dish soap right when a customer is turning on a dishwasher. So there's all kinds of really interesting things that you can do with this kind of data. And it also feeds into the next use case, which is our home apps.
Yeah, so there's integration into different apps into the home. An example is a thermostat. So the thermostat, for example, you can combine runtime with pricing data and the meter time and actually understand exactly what you're spending money on with regards to the signature monitoring, and that's just a continuation of that. So it really, as I mentioned earlier, you're going from simple to complex. This ends up being a little bit more complex. From that point, the customer also has the ability to control usage management, which is the next slide. This gives the customer the ability to control devices throughout their home. So, for example, they can control everything from how much electric they buy off the grid as compared to what they might pull in off the solar panels or other type of devices that they have. But this just adds more complexity to the homeowner and to the decisions that the homeowner makes. Pricing is a key component in this. As we move into the next application, which is total home energy management, this is the ability for the homeowner just to control everything in their home, from solar feeds into their home to what they might buy off the grid, to what they actually use and how they use the power inside their house. So it's the kind of culmination of a lot of early apps that are being brought into the homeowner's purview to actually control their energy consumption. And the great thing about this is we've gone from utilities where the customer has no say in how much they use or don't have any idea on how much they use, to total control over what they use. So it's an interesting proposition, and it gives the customer more control, which leads into the next topic, which is where customers actually have the control to add power back into the grid.
So this idea of a prosumer is relatively new. Sort of started in California, which you have a lot of rooftop solar in California. In fact, they get so much solar in California that at times customers have more solar energy than they can use, and really want to actually be able to sell that or export that to the grid. So at certain times a customer is consuming, and certain times they're producing. And it really kind of changes the entire paradigm of how you think about a customer, because a customer is effectively also a supplier, and the home is effectively a node on the grid. So this starts to impact utilities dramatically, because you can have power going in two different directions. So now your smart meter not only has to measure how much the customer is using, but how much is the customer exporting. There's all kinds of debate as to when a customer does export, what rate do they export at? Are they exporting at a wholesale rate, or are they exporting at a retail rate? And there's lots of policy issues being discussed in states on that particular issue. But we're getting into really a tremendous opportunity here for customers' choice. And I see we've got enough time for this. So Lucy, I'm going to deviate and here for a second, because somebody just reminded me of a customer app that we forgot. And if you could put up the remote disconnect slide, Lucy, can you find that one? Yeah. So this is a use of a remote disconnect, and it's called prepayment. And Dave Elvey from Pago would not forgive me if we didn't talk about this. But basically, an idea with prepayment is this used to be sort of a negative, where utilities would use prepayment on customers that were non-pay customers, and they would disconnect them. And it was utility commissions didn't like this. Well, we've really been able to repackage prepay with, you've got a meter here with this remote disconnect feature. It's got communications and it's got software, such that a customer, either with a smart card or a smart key or over the air, can actually charge up their meter ahead of time with a certain amount of usage. And then as they used the commodity over a given month, they can see actually what's going on, how much they're spending. And if in fact they run out, the meter turns itself off, the customer is empowered to turn themselves back on. And now you're finding lots of customers that really they feel empowered by prepayment, and it's again another version of customer choice. And prepayment is really making a renaissance in this country, and it really is enabled by this remote disconnect. So Lucy, sorry for the deviation there. If you could get us back up to up to renewables.
Well, Ross, I think a lot of that prepayment was originally years ago when utilities had meters that you put coins in.
Yeah.
So that was the original type of prepayment. The customer actually pays attention to their usage a lot more than paying a bill at the end of the month. So I'm glad you brought that up.
Yep. Yeah. So the next one is renewable energy, and you know what we're trying to get to here is utilities today are really looking for ways to communicate with their customers as to what's going on and educate them about what's happening with renewables and carbon footprints and so forth. So there are applications now that are being developed. One of them is by a company called Seabreeze, actually competed in the Clean Tech Open not too long ago, which actually measures in real time how much renewable energy is on the grid, and then can integrate that with some of these customer home apps that we talked about. Can integrate with your Nest thermostat, can integrate with your Tesla charger. And so it will communicate to you what the optimal time to use more energy, not just use less. And typically what happens when you've got more renewable energy on the grid, the prices are lower too, because of usually the variable cost of producing renewable energy, wind and solar, is close to zero. So we even now have social media and gamification where customers are actually competing with each other to see who can use the most renewable energy at the right time during the day. And it's a really cool way for utilities to achieve customer engagement, especially with the utilities that are trying to make very high renewable portfolio standards in the marketplace. And it's really an interesting way that this is evolving. The next category we've got here is retail applications. And the first one that I want to talk about is community choice aggregation. So think of this as a town or a community, a county, of customers, both residential and commercial customers, that will basically opt out of providing getting their retail supply from the utility. They're still using the poles and wires, but the CCA is going out and procuring their own power in the marketplace. And these are typically opt-out programs, meaning if a community chooses to go CCA, all the customers in that community are going to be in the CCA unless they decide to opt out. And why do they do this? Well, typically these are communities that want to be more aggressive with renewable energy, or they want to be more aggressive with energy efficiency. They've got some social objective here. They want to get more renewable energy for low and middle incomes customers. And this is really taking off. It's certainly taking off in California. I know there's a number of CCAs that are in Illinois now. There's a number of CCAs in New York, and they're really gaining traction. The next one is kind of similar to this, but it's called community solar. And if you think about this, if you're a residential customer and either your roof faces the wrong direction, or you've got tree cover on your roof, or you don't have a roof, you're in a condominium or an apartment, you really are kind of frozen out of the ability to get renewable energy and solar until community solar came along. And I should say, or if you're in a financial situation where you cannot afford the capital to put a $10,000, $20,000, $30,000 of solar panels on your roof, this community solar idea has been around for a little while. It really started out in a couple of states, and the idea is to bring renewable energy to folks that normally wouldn't be able to get it. There's about 75 to 70% of the population that would be kind of frozen out of solar. So what'll happen is a third-party developer will go out and build a solar farm. And these are typically a much smaller scale than what we call utility scale. Those utility scale plants are hundreds of megawatts. These are usually 5, 10, megawatts. And two of the larger providers of community solar, NextEra, the big utility in Florida, is a big provider of community solar. And Goldman Sachs, and the Wall Street firm, is also building a number of these community solar facilities. And the idea is that they will build them, and then individual retail customers, both residential and commercial customers, can subscribe to the output of that solar farm. And these one unique aspect of these solar farms is they are not connected to the transmission system like utility scale solar. They're connected to the distribution system. And you can, as you subscribe to these, you can offset not only the energy cost on your bill, but you can offset essentially the entire bill. So typically on your electricity bill, about a third of it is going to be the commodity, about a third of it is going to be the T&D charges, and about a third of it is going to be all the back office, the billing, customer service, all that kind of thing. Well, you can offset that whole bill with community solar, and also get a discount. Typically, you're going to get about a 10% discount when in these community solar programs. So they're very popular. I mean, customers love being able to get renewable energy. They love being able to save money, and they're been extremely successful in the Northeast, particularly in Massachusetts and New York. And now we have 19 states in the U.S. that have community solar programs. So this is growing like a weed. And I expect it's going to continue to grow quite a bit, particularly in states that have these high renewable energy portfolio standards, which gets us to the next application, which is transactive energy, which is kind of futuristic.
Yeah, well, thanks, Ross. Community solar is almost like being in a co-op where, okay, let's say that you've got some people that put power into the grid, and they don't want to necessarily sell it to the distribution owner or operator. So what transactive energy is, it's the ability of two different people having a financial relationship where the grid actually does the delivery of the commodity to each other. So the whole idea is the grid doesn't, or the utility doesn't have to get involved. The two people have a transaction and they ship it over the utility wires, kind of like you would do with trucking. But at the end of the day, the transactive energy is something that is done electronically between two people or two organizations. A lot of times it's a new technology called blockchain, which is a financial type of transaction service. And the utility doesn't even really know it happens for the most part, except they get their share of what's being delivered to the end customer. But the commodities is actually, it's like a trading floor for individual people. And so it really is something that you're going to see come up time and time again, where people have an overabundance of electric generated by their solar panels or whatever they've got on their facility. It could be some type of turbine. It could be a windmill. It doesn't matter what it is, because the transactive energy is just the transaction between two different people. Which takes us into Ellen, kind of going to wrap up these topics for us.
Yeah, there you go. 21 different uses for meter readings. We even got a couple bonuses in there on the smart meters themselves. There's lots more really on those, but we got a couple bonuses for today. So we've got a PDF summarizing all these meter reading use cases. It's available for download on our website. So visit cleargrid.io and download that. Also find out more about gathering smart meter readings with clearGRID. And if you have any questions, feel free to send them in. You can also submit through the website. Thank you everyone for joining, and have a great day.